Okay, we're going to continue with categorical propositions. Right here, I want to talk about two more terms here, and this is actually still part of section 4.1, okay? I went over A, E, I, and O, the categorical propositions, the four Aristotle used to relate classes, all, part, included, excluded from a predicate class, A, E, I, and O. And this is part of section 1. Okay, so two more terms. Let's talk about quantifiers. You know, in some of those sentences, you know, all S or P, no S or P, some S or P, some S or not P. If you have all, no, or some, these are called quantifiers. And they specify how much of the subject class, all or part, is included or excluded from the predicate class. So those are called the quantifiers. You've seen them before, but I haven't pointed them out and given them a label. You know, they call those quantifiers. And then you have copula or couple, and this is when you had all S R P, no S R P, some S R P, some S are not P. These terms are called the copulas or the couples. They couple the subject and the predicate class, include or exclude. And sometimes your textbooks will have is and is not. It's the same thing. Don't get confused about that. Our textbook, I believe, uses are and are not. But if you ever see is and is not in one of the exercise problems, they mean the same thing. So they couple the subject term with the predicate term. So two terms here, okay? Quantifiers and the copula. So with everything that we've done so far, let's look at this statement here, this proposition, and see if we can identify the quantifier, the subject term, the copula, and the predicate term. Okay, this is basic stuff, but you have to know this stuff. It's kind of your bread and butter for a lot of the things we're going to do in chapter 4 and 5. So let's see if we can identify in this proposition all members of the American Medical Association are persons holding degrees from recognized academic institutions. Okay, so what's the quantifier? Well, the quantifier is right here, right? That's not that hard. All. So we'd write all. Okay, what's the subject term? Members of the American Medical Association. Okay, members of the American Medical Association. This is your subject term. So we'll write that out here. Members of the American Medical Association. That's your subject term. Okay, the copula is right here, is are. Okay? So that would be are. And your predicate term is persons holding degrees from recognized academic institutions. Persons holding degrees from recognized academic institutions. Okay? So that's pretty straightforward stuff. Now, sometimes you've got to be careful. You could have in the predicate the word are or are not, like all members of the American Medical Association are persons who are not unlicensed physicians. So persons who are not, that's part of the predicate. You don't want to confuse an are or are not in a subject or predicate term with the real copula that's connecting the subject and the predicate term. You just got to be careful because sometimes subject and predicate terms can have are and are not in them. Just don't get them confused with the real copula. Okay? And you know at your book, if you go through the book, they're going to give you some devices. If we switch gears here a little bit about distribution, right? And you remember I told you when I did the first two videos, I kind of was redundant, I was repetitive, I used overly wordy sentences to try to get you at least the concept of distribution. But I told you later on I'd give you a cheat sheet, and I am, and this is really what you'll need, just need to kind of do some of the exercises later on and understand the concepts. but you want to go deeper on your own and understand why a term is distributed or undistributed. But the book actually gave you two techniques, and you can use these if you want. Unprepared students never pass. The U, the S, the N, and the P stands for universals distribute subjects, and negatives distribute predicates. You can use that. You can study this one. Any student earning B's is not on probation. A statements, the A is for the S, student statements, distributes the subject. E statements distribute both terms. I statements, neither, and O statements distribute the predicate. That's what the A, the S, the E, the B, the I, N, O, and P stand for. You know what? Here's what I recommend. This is my method. I thought it up, but probably you would too. Why don't you just write out the 4 categorical propositions, and you know what? I have all S or P. Write a little D next to that S. No S or P. Write a little D next to that S. A little D next to this predicate, the P standing for the predicate class. None here for the I statement. And write a D here. So I recommend doing this, just so you know with the 4 categorical propositions which one are distributed or not. If you guys like doing this, fine. I think this is just an easier cheat sheet. Okay, so that's my recommendation. Okay, now there's 2 more terms. So basically right here, this was 4.1. Okay, this was all the rest of 4.1. Now let's go to 4.2, and they talk about 2 more terms. We'll talk about these real quick, and then the next video I'm going to show you how to do Venn diagrams, okay? Because that's another way to conceptualize how classes are related, and it can be used as the way to decide if 2 statements are equivalent and a lot of other things, okay? But anyway, now we're starting 4.2. And here's 2 more terms or attributes of categorical propositions. So you have subject class, predicate class, copula, you have quantifiers. Now we're going to talk about quality and quantity, and these are attributes of categorical propositions. Okay, the quality of a proposition of the 4, they can have one of 2 qualities. It can be an affirmative proposition or a negative, depending on whether the proposition affirms inclusion or denies class membership exclusion. Okay? So affirmative statements would be this: all S are included in P. Some S, and you remember some in logic means, again, at least one. Okay? At least one. Alright, that's what some means. So here, it's affirmative if it's including the subject into the predicate class, all or part. It's a negative quality if it's excluding all or part of the subject class from the predicate class. So no S or P is saying you're not going to find one single S that's in P. All of S is excluded from P, so it's negative. Here it's saying at least one member of S is excluded from P, so it's negative. Here it's saying every member of S is included in P, so it's affirmative. At least one member of S is included in P, it's affirmative. So affirmative and negative, these 2 terms here refer to quality. Okay? Quantity is, of the 4 propositions, they can not only be affirmative or negative, they can also be universal or particular. And it's universal or particular depending on whether the statement makes a claim about every member or just some. And there it is again, just some means at least one in logic. Okay? So either universal or particular is quantity. Those are the 2 terms that you use. If you say universal or particular, you're talking about quantity. You say affirmative or negative, you're talking about quality. But for quantity, if something's universal or particular, this depends on whether the statement makes a claim about every member or just some members of the class denoted by the subject term. So here's 2 propositions that are universal. Is the A proposition, all S or P, talking about every one, and no S or P, because when they say no S, they say every single S is not a part of P, so that is going to be a universal. It's not talking about at least one member or part of the members. All S, and when you say no S or P, that's another way of saying every single S is not going to be found in P. Particular, these are real easy. It's always going to have the word some. Some S or P, some S or not P. That is a particular statement. Okay, now what we're going to do with the next video is I'm going to introduce you to Venn diagrams. Venn diagrams look like this, and remember, I haven't taken drafting classes. I've got a better diagram coming up with perfect circles, don't worry. And here's the S class, and here's the P class, and those four categorical propositions, A, E, I, and O, they can be diagrammed using Venn diagrams, and this is invented by Dr. Venn. I should know his first name, and I'm assuming he has a doctorate. He's the one who invented these diagrams and the shading. So we're going to talk about how you can represent the categorical propositions into some kind of more of a graph form, because they're going to be helpful later on. Okay, so we're going to go that into the next video.